we discuss some numerical problems and conceptual questions on the chapter of liquid solutions. At the beginning, we discussed some questions related to concentration terms, that is molarity, normality, molality and all. Then we go to the conceptual questions on colligative properties, then also some difficult level numerical problems on colligative properties and ideal and non-ideal solutions. So, first let us look at the questions on concentration terms. Now, the first question is, in the question number 1, what it says is, how much of sodium hydroxide is required to neutralize 1500 cc of 0.1 normal HCl. So, it is the neutralization of sodium hydroxide and HCl. And neutralization, what we get is NaCl and H2O. This is the reaction. So, for any of this kind of reactions, first it is better to write the balanced equation for the given reaction. Now, here the mole ratio is 1:1. To solve this kind of questions, the formula that what we are supposed to use is that M1 V1 by N1 is equal to M2 V2 by N2. Now, M1 V1 N1 are the molarity, volume and stoichiometric coefficient of sodium hydroxide, and this is for HCl. Now, the question asked is how much NaOH is required. Then, so here for sodium hydroxide, this M into V, I will keep it as it is. N1 is of course the stoichiometric coefficient is 1 according to the balanced equation, and molarity of HCl is nothing but normality. For HCl being a monobasic acid, molarity and normality are same. So, molarity I will take it as 0.1 and volume of HCl given is 1500 cc. So, that is 1.5 liters divided by it is 1. So, from this number of moles of NaOH required is equal to nothing but M into V, that is equal to 0.1 into 1.5, that is 0.15 moles. So, weight of sodium hydroxide is what we are supposed to find. Number of moles is equal to weight by gram molecular weight. Gram molecular weight of sodium hydroxide is 40. So, from this weight of sodium hydroxide is equal to number of moles, that is 0.15 into molecular weight of sodium hydroxide, that is 40. So, it is 6 grams. So, it is a 6 grams. So, the answer is option B. Now, in the question number 2, the given is 5 ml of 1 normal HCl, 20 ml of 0.5 normal sulfuric acid and 30 ml of 0.5 normal nitric acid are mixed together, and the volume is made to 1 liter. The normality of the resulting solution. For the resulting normality to determine, when you mix 3 different solutions of same solute. Here what we have to take, even though solute by acid nature, if they are different, HCl, sulfuric acid and HNO3, but all of them being acids, we can consider them as the 3 different solutions of same solute. Here the solute being H plus are mixed, then the resultant normality is equal to N1 V1 plus N2 V2 plus N3 V3 by V1 plus V2 plus V3 or V, that is the final volume. So, now in this question what it is given is 5 ml 1 normal HCl. So, it is 5 into 1 plus N by 2 means 0.5 normal 20 ml, 0.5 into 20 plus that 20 ml of 0.5 normal nitric acid. So, it is again 0.5 into 20 divided by total volume. Total volume is made to 1 liter. So, here because the volume is taken milliliter, so here also if we take it in milliliter, it comes out to be 1000. All this now in the numerator, if you add it up, you get it as 25 by 1000. So, this is normality is nothing but 1 by 40. This is what we call n by 40. So, the resultant normality is n by 40. So, the answer must be option D. Move on to question number 3. In this question number 3, what it says is, two solutions of a substance, that is non-electrolyte, are mixed in the manner of 480 ml of 1.5 molar and 520 ml of 1.2 molar. Both the solutions are of same solute. Then what is the molarity of the final mixture? This is again similar to the previous question, that is question number 2, that the resultant molarity is what we have to do. Resultant molarity is equal to M1 V1 plus M2 V2 by V1 plus V2. This if we do, that M1 given is 1.5 molar, 1.5 into volume 480 plus, then M2 V2 is 1.2 molar 520 ml divided by V1 plus V2, that is 480 plus 520. Now, this if you do the calculation, then we get it as 1.34 molar. So, the answer is 1.34 molar, that is option D. Now, let us go to question number 4. Which of the following should be done in order to prepare 0.4 molar NaCl solution? If we are given a solution of 0.3 molar NaCl 100 ml. So, it is basically how to get 0.4 molar solution from 100 ml of 0.3 molar NaCl solution. So, given is 100 ml 0.3 molar NaCl, required is 0.4 molar NaCl. So, this is 0.3 molar 100 ml. So, given number of moles is molarity into volume in liter, that is 0.3 into 100 ml means 0.1, that is 0.03, right, 0.03 moles. Now, required is, suppose if you keep the same what you call volume constant, then required number of moles will be, again if you write m into v, this is 0.4 into 0.1, that is 0.04. So, adding 0.01 moles, 0.03 is given, required is 0.04. So, if you keep the volume constant, then if you increase the number of moles, then how many number of moles that we should increase? We should increase the number of moles by 0.01 moles. So, adding 0.01 moles of NaCl. This is with respect to number of moles. Now, with respect to weight, if you do, that is nothing but what you will get, 0.01 mole by weight, NaCl molecular weight, gram molecular weight of NaCl is 58.5. So, weight of 0.01 mole is equal to 0.585 grams. So, 0.01 moles is nothing but 0.585 grams of NaCl. So, either by 0.01 mole or 0.585, both are same. By adding NaCl, we can increase the concentration. But suppose if you evaporate water, also you can increase the concentration. But if you evaporate water, say like in the one of the options that is given, if you add 10 ml of water, if you evaporate 10 ml of water, what will happen? Volume becomes 20 ml, but this remains 0.3. So, 0.3 into that 10 ml water, if you evaporate, it will become 90 ml, means 0.09. 0.09 into 3, we do not get 0.04, we do not get it. So, first of all, to increase the concentration, there are two things, either we have to add the solute or we have to reduce the volume of the solvent. But from the options, if you reduce the volume of the solvent by 10 ml, we do not get the required concentration. So, the only option left is addition of solute. Then what amount of solute? 0.01 mole, which is nothing but 0.585 grams. So, the answer must be option B, that is 1 and 3. So, our correct answer is option B. Now, let us go to the question number 5. The question asked is, what is the mole fraction of the solute in 1 molal aqueous solution? 1 molal aqueous solution. 1 molal aqueous solution means it is 1 mole of solute in 1 liter of water. 1 liter of water is nothing but the 18 grams, by taking the density as 1 gram per ml for that. So, then it is number of moles of water. So, it is 18 grams of water, which is equal to 55.18 grams of water in 1000 ml. So, it is 55.5 molar. So, it is number of moles of solute is, and solute is 1 mole and solvent is 55.5, because this is 18 by given weight by molecular weight, that is 1000 by 18, that is 55.5. 1000 ml is nothing but 1000 grams for water, 18 grams in 1000 grams. So, it is 18 grams is molecular weight and 1000 ml. So, that is 1000 grams. So, that is 55.5 molar. So, it is number of moles of solute is 1, number of moles of solvent is 55.5. So, mole fraction of solute is equal to number of moles of solute by number of moles of solute plus number of moles of solvent, that is 1 by 55.5 plus 1, that is 1 by 56.5. So, this 1 by 56.5 is nothing but what we get it as 68 by 77. So, the answer must be option C. Now, we move on to question number 6. So far, after question number 1 to 5, we discussed about the numericals, simple numericals based on the molarity, mole fraction, molality. Now, we go to the conceptual questions of colligative properties. Now, the first question that is given here is that common salts like sodium chloride or anhydrous calcium chloride are used to clear the snow on the roads. This is what is actually what we observe, especially in the cold regions. In order to melt the snow on the roads, the salts like NaCl or CaCl2 are added. What happens when these salts are added? The reason for this is to clear the snow, it has to be melt. In order to melt, as the temperature is very low, the melting of ice at that low temperature is not possible. So, by adding these salts like NaCl or CaCl2, we reduce the freezing point. We reduce the melting point of ice, or the other way nothing but lowering the freezing point of water. So, what basically we are doing is, it is a concept, it is a question based on the concept of depression in freezing point. In the depression of freezing point, what we say is, when a non-volatile solute is added to a pure solvent, the freezing point of the solution becomes less than the freezing point of the pure solvent. So, here basically we are reducing the freezing point. So, this is nothing but lowering in freezing point of water as well as lowering in melting point of ice. The other way that what we are saying is, ice melts at the temperature of atmosphere present at that temperature, at the temperature of the atmosphere present at that time. So, by adding that, what we are doing is, either we are lowering the freezing point, and we see that ice melts at that particular temperature, whatever the temperature that is existing at that particular pressure. So, it is all A, B, C are the correct answers. So, the option must be, the correct option must be the option D. Now, in the question number 7, this is another conceptual question. Assuming each salt to be 90% dissociated, which of the following will have highest osmotic pressure? This is, all the given salts are dissociated by 90%. First of all, for the osmotic pressure, we have the formula that pi equals to C St, where pi is the osmotic pressure, C is the concentration, and with the help of Van 't Hoff factor also if we introduce, then ICST. I is the Van 't Hoff factor, C is the molar concentration of the given salt, S is of course the solution constant, which is same as the gas constant R, it is a constant, and T is the temperature. Now, for all decimolar solutions, decimolar solution of aluminum sulphate, decimolar solution of barium chloride, decimolar solution of Na2SO4. Now, all these three if you look at it, then for the first one pi 1 is equal to, for aluminum sulphate, as it is involving 2 cations and 3 anions, the total I factor is 5. 5 into concentration is of course the decimolar, that is 0.1 into S into T. Like this, for all this if you look at it, barium chloride 5, it is 3 into 0.01 and that is pi 2. Pi 3 is sodium sulphate. Sodium sulphate is 1 sulphate ion and 2 sodium ions. So, that is again 3 into 0.1 into St. So, it is basically these terms if you look at it, the highest value is for this. Of course, in the fourth option once what it says is solution obtained by mixing equal volumes of B and C. B is barium chloride, C is sodium sulphate. Barium chloride, sodium sulphate if you mix, what happens is you will get a precipitate of barium sulphate. So, this will not contribute anything towards the osmotic pressure. The reason being that barium sulphate being a precipitate is not dissolved, so it will not contribute towards the osmotic pressure, but what you will get is NaCl. But NaCl I factor is only 2, right? And even if you consider the 2 NaCl, so what you will get is 2 into 2, that will become 4, but definitely not 5. So, all I factor for all of them, for all the B, C, D options are less than the I factor for, that is Van 't Hoff factor for the first option. So, the answer, higher the Van 't Hoff, higher the concentration IC, higher the osmotic pressure. So, the answer must be option A. Now, in the question number 8, it says the boiling point of an azeotropic mixture of water and ethyl alcohol is less than that of the theoretical mixture. Boiling point of azeotropic mixture of water and ethyl alcohol is less than that of the theoretical mixture, means it is this minimum boiling azeotrope. The boiling point of the mixture, azeotropic mixture, if it is less than the boiling point of either of the liquids, then we call it as minimum boiling azeotrope. So, what kind of deviation that the azeotrope shows from ideal behavior? Here the concept is that ideal solution, if it is ideal solution, then it will not form azeotropic mixture at all. Ideal solutions do not form azeotropic mixture during the distillation, fractional distillation. That means, if it is an ideal solution, the ideal solution again can be separated back into the pure components. But if it is non-ideal solution with positive deviation, then it will form minimum boiling azeotrope, minimum boiling. And if it is a solution with a negative deviation, then it will form maximum boiling azeotrope, minimum boiling and maximum boiling. And here in our given question, it says that the water and ethyl alcohol has a lesser boiling point. Lesser boiling point means low boiling azeotrope or minimum boiling azeotrope, that is formed by non-ideal solution with positive deviation. So, positive deviation from Raoult's law, that is positive deviation from ideal behavior, should be the correct answer. So, the correct option is option B. Now, let us move on to question number 9. At high altitudes, the boiling of water takes place below 100 degrees Celsius because at high altitudes, boiling point of water is less than 100 degrees Celsius. What is the reason? What is first of all boiling point? Boiling point is temperature at which vapor pressure of liquid becomes equal to atmospheric pressure. Now, at higher altitude, what will happen? At higher altitude, atmospheric pressure decreases. Therefore, the vapor pressure required for the temperature required for the solution to reach the atmospheric pressure also decreases. Therefore, boiling point decreases at higher altitudes. As we go to higher altitudes, atmospheric pressure decreases. As the atmospheric pressure decreases, the liquid reach that atmospheric pressure fast, more at a relatively lower temperature, means the boiling point decreases. So, the atmospheric pressure becomes low should be the correct answer. So, the correct option is option A. Now, let us move on to the question number 10. The factor delta Tf by Kf. Delta Tf by Kf. What is delta Tf? Decrease in freezing point. What is Kf? Molarity pressure constant. Now, from the colligative properties, what we have learned is that delta Tf is equal to Kf into molality. Delta Tf is equal to Kf into molality of solute in the solution. So, delta Tf by Kf, so should be equal to what? Into is equal to molality. So, it is a direct simple question that the answer is molality. So, it should be option D. Now, we go to question number 11. In the question it says that in cold countries, ethylene glycol is added to water in the radiators of cars during the winter season. What is the reason for that? The reason is that upon adding ethylene glycol to water, the freezing point of the water is lowered over there, due to which formation of ice will be prevented, and finally radiators can be allowed to keep working. So, the reason is that addition of ethylene glycol to water to be used in radiators in cars during winters in cold countries is to lower the freezing point of water. So, the correct answer is option D. In the question number 12, the melting points of most of the solid substances increase with an increase of pressure acting on them. However, ice melts at a temperature lower than its usual melting point when the pressure is increased. This is because here normally, suppose if the atmospheric outer pressure, surroundings pressure or atmospheric pressure is low, then the melting point of the solids will increase, because the atmospheric pressure when it is lowered, then the ice freezes at a lower temperature, the water freezes at a lower temperature, or the melting point is increased the other way around. But in the case of ice, what happens is that the density of ice is less than the density of the water. In fact, that is the reason that ice floats in water. Normally, for a solid, for a particular substance in its solid state, the density will be more compared to that in the liquid state. But in the case of ice, the density of the ice is less than that of water due to weak hydrogen bond in ice. Hydrogen bonding is strong in liquid water, due to which ice gets a cage like structure, which decreases the density. And finally, with the increase in pressure, the melting of ice is lowered, whereas for other solids it is increased. So, the correct answer is option A. In the question number 13, that camphor is used as a solvent to determine molecular weight of a non-volatile solute by RAS method. Because what is the reason that to use camphor as a solvent? The reason is that molar depression constant, that is Kb, that is delta Tb is equal to Kb into molality, right. If the Kb is more, then we will get a large difference in the boiling point. That large difference is convenient to measure the exact values. If that difference is very small between the solute and between the solvent and the solution, then it is difficult to measure. But if the Kb is more, then this delta Tb will be more. So, it is very convenient to read the measurement, the temperature on the thermometer scale. Therefore, that camphor with a high molar depression constant is Kb or Kf, molar depression constant, that is Kf. Delta Tf is equal to Kf into molality, delta Tb is equal to Kb into molality. So, whether it is any substance whose Kb is more or whose Kf is more, if we use, then we will get a large difference in the melting point or boiling point. Therefore, for that convenience, camphor is used in RAS method as the solvent. So, the correct answer is option C. In the question number 14, it is given that two solutions, A containing FeC aqueous FeCl3 and B containing potassium ferrocyanide. A is FeCl3, B is K4FeCN6, potassium ferrocyanide, both aqueous solutions are separated by semi-permeable membrane. So, here what you have is membrane. When you are having a membrane like this, now if FeCl3 on reaction with K4FeCN6, now actually if these two are in contact, then K4FeCN6 on reaction with FeCl3, that will give you Fe4FeCN6 thrice ferric ferrocyanide, and this ferric ferrocyanide is a blue colored substance. So, as a result, when these two, when they come in contact and they react, we get blue colored solution. Now, the question is that because of this reaction, the blue color will be noticed in either in A or in B or in both or none. No doubt that when these two will react, we will get this blue colored ferric ferrocyanide, but this being a semi-permeable membrane, it allows only the flow of solvent, that is water. Water only flows from A to B or B to A depending on their concentrations. So, it is only solvent transfers from A to B or B to A, but neither FeCl3 nor K4FeCN6 will pass through membrane. That means, because it is a semi-permeable membrane, SPM is what we call, it allows only the flow of solvent, but no solute. So, FeCl3 will remain here, K4FeCN6 will remain here. So, there is no possibility of these two to come in contact and to give any blue colored ferric ferrocyanide. So, there is no chance of formation of blue color either in A or B. So, the answer is option D. Now, we go to question number 15. Now, in the question number 15, what it says is, for an ideal binary liquid solution, binary liquid solution means one solute and one solvent. A mixture of a solute and solvent is what we call binary solution. That means, we do not have more than one solute. Solvent is of course, every time it is only one, but number of solutes can be 1 or 2 or 3. But when we have only one solute and a solvent, then what we call it as binary, right. Then Pa naught is greater than Pb naught, means vapor pressure of solvent A is greater than the vapor pressure of solvent B. Then what is the relation between XA, that is mole fraction of A in the mole fraction of A in the liquid phase. In the liquid phase it is XA and here it is XB. Then in vapor phase it is YA and this is YB. Now, because PA naught is greater than PB naught, that means vapor pressure of A is more than vapor pressure of B. When vapor pressure of A is more than vapor pressure of B, that means TA naught will be less than TB naught. That is, boiling point of pure solvent A is less than the boiling point of pure solvent B. So, that means A is more volatile. A is more volatile compared to B. B is less volatile. Right. So, as a result, what? In vapor phase, therefore, at any instant in vapor phase, A is more, implies YA is greater than YB and XA is less than XB in the liquid phase. During fractional distillation, your vapor will have more of A and liquid will have more of B. As a result, what you will get is XA by XA by XB. XA by XB. XA is a smaller quantity than XB. Obviously, YA is a larger quantity, will be less than YB. So, in vapor phase, YA is greater than YB, liquid phase XA is less than XB, therefore, XA by XB is less than YA by YB. So, the answer must be option C. Now, let us go to question number 16. Each pair of which of the following forms a non-ideal solution? In fact, the question is like we have to read it as 4 different pairs of solutions are given, 4 different pairs of liquids have been given. The combination of which pair will not give an ideal solution? For 2 liquids to form an ideal solution, the necessary and sufficient conditions are that structurally both the compounds must be identical, molecular weight difference should be less, and the physical and chemical properties must be much closer to one another. So, in that sense, if you look at it, the first option is that ethyl bromide and ethyl iodide. So, ethyl bromide, ethyl iodide both belongs to same family of compounds, and the next is again the similar case that ethyl chloride and ethyl bromide, that is also the same. All 3 of them, ethyl bromide, ethyl chloride, ethyl iodide, all of them are alkyl halides and with a close relation in their melting in the molecular weights and intermolecular forces and all. Benzene and toluene is of course also same family. I mean, they are like a homologous series of compounds, right. But when you come to the option 4, option D rather, that is ethyl iodide, which is an alkyl halide, and ethyl alcohol, which is an alcohol. Between alkyl halide and alcohol, we cannot expect any similarity in their intermolecular forces. Not only intermolecular forces, either physical and chemical properties are going to vary very much. Therefore, such kind of pairs, dissimilar pairs. The first 3 are similar pairs, but the last one is a dissimilar pair, and that kind of dissimilar pairs cannot form an ideal solution. So, the answer must be option D. Now, in the question number 17, which of the following conditions is not satisfied by an ideal solution? Means, in the preparation of an ideal solution, which of the following is not followed? Which of the following condition is not followed? Delta H mixing is 0. Yes, in the formation of an ideal solution, that means when 2 liquids are mixed to form an ideal solution, there won't be any change in the volume. Also, there won't be any change in the enthalpy, neither the heat is evolved nor heat is absorbed if it forms an ideal solution. And at the same time, an ideal solution is the one which obeys Raoult's law. So, the options cannot be A, B and D. So, obviously it is the delta S mixing is 0. The entropy of mixing will be greater than 0. In the formation of an ideal solution, delta H mixing will be 0, delta S mixing will be positive, and delta G mixing will be negative, because formation of an ideal solution is a spontaneous process. For a spontaneous process, delta G is less than 0. When delta G is less than 0 and delta H mixing is delta G mixing is less than 0, delta H mixing is equal to 0. So, delta G is equal to delta H minus T delta S. When you do, then this is negative, this is 0. So, for this total to become negative, then delta S must be positive. So, that means it is not equal to 0. So, the incorrect statement is the option C. So, the correct answer is C. Now, let us move on to question number 18. It is given in the question that two solutions of KNO3, potassium nitrate and acetic acid, are prepared separately. Molarity of both is 0.1 molar. This is 0.1, this is also 0.1. Right. And osmotic pressures are P1 and P2. Osmotic pressure of this is P1 and this is P2. Now, the correct relationship between the osmotic pressures of both is, that means whether P1 is equal to P2 or P1 is less than P2 or P1 is greater than P2. Now, this being a strong electrolyte will dissociate completely to K plus and NO3 minus. So, for this I factor will be 2, but this is a weak acid. So, this will it is only undergo partial dissociation. Okay. So, here I will be less than 2. So, as a result, when you apply pi equal to I into C into R into T, C is of course both is 0.1, this is same, these two are same. So, this entire factor is same. So, now osmotic pressure is dependent only on I, for whichever case I is more, that is 2 for KNO3, that will have more osmotic pressure. So, it must be that P1 must be greater than P2. So, P1 must be greater than P2 or P2 is less than P1. P2 is less than P1 is should be the answer. So, the correct answer is option A. Now, let us go to question number 19. The value of Kf for water is 1.86 Kelvin kg per mole. Kf for water is 1.86 Kelvin kg per mole. This is the one that is calculated from glucose. This is the calculated value from glucose solution. Then the value Kf, the value of Kf for water calculated from NaCl solution. For NaCl solution or glucose solution, for any solution, delta Tf is equal to Kf into molality. So, whatever the solution you take, if molality and delta Tf are same, then Kf also will be same, or in other words, delta Tf by molality if same, Kf will be same. So, otherwise Kf is a constant value for a solvent. It is not dependent on what solute it is. Kf is what? Molar depression constant of solvent. Here what is the solvent? Either you take glucose solution or you take NaCl solution, solvent is water only. So, Kf is a constant for the solvent, that is for water. So, whatever the solution we take, Kf will be same. So, for any solution of where the solvent is water, the value of Kf is always 1.86 Kelvin kg per mole. So, the answer must be option A, 1.86 only. Let us go to question number 20. This question number 20 says, the molecular weight of benzoic acid in benzene as determined by depression in freezing point method corresponds to benzoic acid C6H5COOH in benzene solvent. It undergoes what? That it undergoes dimerization. So, what you will get is you will get the dimerization like this. So, molecular weight what we will get here is the molecular weight of this will be twice, molecular weight is twice to that of normal benzoic acid. So, in benzene as it undergoes dimerization, so the molecular weight formed over here, molecular weight that it determined over here corresponds to dimerization of benzoic acid, but not ionization, not trimerization or not solvation, it is dimerization. So, the correct answer is option B. Now, let us go to the question number 21. There is another conceptual question which says that a pressure cooker reduces cooking time because heat is more evenly distributed, boiling point of water inside the cooker is increased, high pressure tenders the food and all the above. It is the pressure cooker, as the name itself is indicated, when it is tightly closed. Here what actually we are doing is we are increasing the pressure inside. When we are increasing the pressure inside, what happens? The boiling point increases, because boiling point is what? The temperature at which the pressure of the vapor pressure of the liquid becomes equal to the external pressure. When the external pressure is increased, obviously the boiling point also will increase, because it requires more temperature to reach that increased pressure. So, as the pressure is increased, the external pressure is increased, the temperature required to reach that increased external pressure also will increase, that increases the boiling point. In fact, by increasing the boiling point, what we are doing is that water will absorb more heat and it will allow the food to cook fast. So, basically the reason is that boiling point of water inside the cooker is increased. So, the correct answer is option B. Now, let us go to question number 22. Now, here the question is about the drawing the plots for 1 by XA versus 1 by YA, where XA is a mole fraction of liquid A in liquid phase and mole fraction of A in vapor phase during fractional distillation. Basically, the point is when we are taking two liquids A and B, a binary mixture when you take, then what actually we know is that the vapor pressure of solution Ps is equal to XA Pa naught plus XB Pb naught, where XA and XB are mole fractions of A and B in liquid phase. Pa naught and Pb naught are their vapor pressures for pure solvents. Then also during fractional distillation, if Ya and Yb are mole fractions of A and B in vapor phase, then also what we can write is that Pa is equal to Ya into Ps according to Dalton's law. Partial pressure is equal to mole fraction of the gas, that is mole fraction of the vapor here, into total pressure of the mixture, that is vapor pressure of the mixture of solutions, that is Ps, which is nothing but XA Pa naught plus XB Pb naught. So, from this what also I can write is Ya is equal to Pa by Ps. Now, this Pa I will write it as XA Pa naught by XA Pa naught plus XB Pb naught. Pa is equal to XA Pa naught, Ps is equal to XA Pa naught plus XB Pb naught. Now, what I will do is I will take 1 by Ya. 1 by Ya is equal to XA Pa naught plus XB Pb naught by XA Pa naught. This is equal to XA Pa naught plus XB is nothing but 1 minus XA into Pb naught by XA PA naught, right. Now, this is equal to, I can put it as that XA PA naught, this is nothing but equal to XA into PA naught minus PB naught plus PB naught by XA PA naught, right. Now, this if I divide it, then I will get it as PA naught minus PB naught by PA naught plus PB naught by XA PA naught. Instead, now what I will do is, I will get that 1 by XA on the left hand side, then what I will get is that this PB naught by XA PA naught is equal to 1 by YA minus PA naught minus PB naught by PA naught, right. Now, this the whole equation I will multiply with PA naught by PB naught. So, when I multiply this with PA naught by PB naught, I will get it as 1 by XA. 1 by XA is equal to PA naught by PB naught YA, and this when I multiply with PA naught by PB naught, PA naught cancel, you will get PB naught. So, this I will rearrange as plus PB naught, I will changing the sign. So, PA naught minus PB naught, I am writing it as minus PB naught minus PA naught. So, minus of minus will become plus by PB naught. So, this is 1 by XA versus 1 by YA. So, it is y is equal to mx plus c. So, this is y like and this is x like. So, this is 1 by XA versus 1 by YA we need to take mx. So, this is m. So, PA naught minus PB naught, this will become the slope and this whole term will become the intercept. So, the slope is equal to PA naught by PB naught and intercept is equal to PB naught minus PA naught by PB naught. So, the correct answer is option B.